Hello everybody, this is Mrs. Snook with section 6.1, which is about the law of sines. And we're going to do this over 2 days, so this is the first half. And our objective is to solve triangles using the law of sines. And by solving triangles, what we mean is you're going to solve for any missing side or angle. So first of all, the triangles we're going to solve today are called oblique, and that means that they don't have any right angles. So if you look at our picture here, there are no right angles in this triangle. And we're also going to use the Triangle Sum Theorem, which you may remember from geometry, that says that all three angles in a triangle add up to 180 degrees. Quick note about notation. When you see a capital letter, that refers to an angle, and then a lowercase letter refers to a side. And what we do is the lowercase side A is going to be opposite angle A, and then side B is opposite of B, and side C is opposite of C. Now here's what our law of sines says. Little a over sine A equals little b over sine B equals little c over sine C. Also works if you flip everything over. And what you need to use the law of sines is an opposite angle pair, opposite angle side pair, where you know both measures. So you would need to know, say, the length of A and the sine of A. That would count as an opposite angle side pair. Same thing if you had b and little b and sine C and little c. Now there's a couple of kinds of triangles that we're going to use today, and the first one is AAS, and that refers to angle side. It means that you know an angle, and a side. So look at this triangle here. We know angle A is 35 degrees, angle B is 54 degrees. This is not a right triangle, so we can't assume that angle C is 180, but we can certainly, angle C is not 90, but we can solve for this. So let's go ahead and solve this triangle. Now what's missing is side B, side C, and angle C. So those are the three that we're going to get. Easiest is to get the angle C right away. So I know that angle C plus 35 plus 54 is going to equal 180. Then to get angle C, all I have to do is subtract these two angles from 180. So 180 minus 35 minus 54 is 91. So now I know angle C is 91 degrees. Now let's use law of sines to get the other two items. So I am given little a is 18 millimeters. So let's go ahead and use that. So I'm going to say, and let's solve for b. So b over sine of b equals a over sine of a. And I've written it this way because I want to solve for b. So then just plug in what you know. Little b is what I'm looking for. Sine of b is sine of 54. Little a I know is 18. And sine of a is sine of 35. And then to solve for b, I'm just going to multiply both sides by sine of 54. So what I'm going to get is little b equals 18 over sine of 35, and all of that's going to be multiplied by the sine of 54. So this is what you plug in your calculator. So just plug in and get an answer. Make sure you're in degree mode, because my problem is in degrees, so I'm switching to degree mode. I'm going to do 18 times sine of 54 divided by sine of 35, and I get 25.4. Now I'm going to do the same thing to find little c. So little c over sine of c is going to equal little a over sine of a. And I'm choosing to use a and sine of a because those are values that I've already been given. So if I make a mistake, it's less likely that this mistake will carry on. So c over sine of 91 equals 18 over sine of 35. And just like last time, you're going to multiply both sides by the sine. So little c is going to be 18 sine of 91 over sine of 35. So 18 times the sine of 91 divided by the sine of 35, and I get 31.4. And these are all millimeters. All right. The next one we're going to do is an angle side angle. So I have two angles and a side that's sandwiched in between them. And I'm going to use law of sines to solve this triangle. First up, let's get angle C. As I know, angle C plus 30 plus 20 equals 180. Therefore, angle C is going to be 130 degrees. And just like before, pick an angle and its opposite side that you know. Well, over here is little c given to us as 30 feet. So little a over sine of a is going to equal little c, which is 30, over the sine of c. Now plug in. And then solving. Just like before, this is going to be 30 times the sine of 20 divided by sine of 130. And that's going to equal 30 times sine 20 divided by sine of 130. And I get 13.4 feet. So on your own, I want you to solve for little b. So pause this video now and solve for little b, and then when you come back, I'll have my solution and you can check. All right, I got 19.6 feet. Now the next one we're going to do, this one doesn't give us a picture, so we're going to have to draw our picture. And I notice I'm being given two angles and a side. So let's draw our picture. And I'm just going to draw my triangle like this. This is going to be A, this is going to be B, this is going to be C. A is 28 degrees, C is 73 degrees, and then little c, which is opposite angle C, is over here, and that's going to equal 30. And then we're going to solve for angle B, and then sides A and C. Angle B plus 28 plus 73 equals 180. So angle B equals, just do 180 minus. This is 79 degrees, and I'm going to put 79 in there. Now let's get A and C, the sides. So little a is over here, and we're getting little b, not c. C is already given to us. All right, try this on your own. Try getting sides A and B. So pause here, and then when you come back, you can see if your work matches mine. All right, so for B, I got 30.8, and for A, 14.7. So check yours and go ahead and make a correction in your notes if you didn't get what I got. Now here, example 4 is a real-life problem. We have a pole tilting towards the sun at an 8-degree angle from the vertical, so careful about that. And it casts a 22-foot-long shadow. And the angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? Now we have a picture already drawn for us. So we can go ahead and what we're figuring out is A, which is going to be how tall, or I think of it as how long is the pole. You know, how tall is it if it was standing straight up? So what we're looking for is little a. And what we have is we have sine of A, and we have B, but notice this is a right angle plus another 8 degrees. So angle B is going to be 98 degrees. And then we can get angle C from this. So 98 plus 43 plus angle C is going to equal 180. So angle C equals 180 minus 98 minus a 43. I get 39. So this angle up in here is 39 degrees. And I need that angle because the only side I'm given is little c. And I have to have an angle opposite side pair. So I can't do anything until I have angle C. So now I'm ready to write my law of sines. I'm trying to solve for A. So little a over sine of A is going to equal little c over sine of C. Now I'll plug in what you know. Little a is what I'm looking for. Sine of 43 equals little c, which is 22, over the sine of 39. And then just like the problems we did before, you're going to multiply both sides by the sine of 43. So a is going to be 22 times the sine of 43, and I'm going to divide that by the sine of 39. And I get a is 23.8 feet. So that is the length of that telephone pole. So that's it for today, everyone. Thank you for watching and have a great day.